Good morning, dear children. Hope you all are fine. Let us continue with the chapter Light, Reflection and Refraction. Children, we know that light travels in straight line path and that propagation is known as rectilinear propagation of light. We know when light falls on a mirror, it is reflected back in the same medium. What happens when light falls on a surface or on an object? We know some amount of light will be reflected, some amount of light will be absorbed by the object, whereas some amount of light will be transmitted. So we are looking into the transmission of light rays by some of the mediums. So when I say medium means it is a material or substance through which light moves. So the rectilinear propagation of light is true as long as the light rays are traveling in the same medium or the same substance having the same density throughout. Now what happens when light rays move from or pass from one transparent medium to another? So let us understand it through the coming slides. Whenever light rays are made to go from one medium to another, the light rays change their direction or they bend at the boundary between the two media. For example, children, you can see here a glass block, and when a ray of light traveling in air goes obliquely into the medium glass, it changes the direction or it bends on entering the glass block. You can see at point A, the light bends and the light enters into the glass. The change in direction in the ray of light occurs again when it goes from glass into air at point B. So children, we can say that the light undergoes refraction at point A and at point B. So what is refraction? The change in the direction of light when it passes from one medium to another obliquely is called refraction of light. Or the bending of light when it passes from one transparent medium to another obliquely is called refraction of light. The optical instruments like camera, microscope and telescope work on the refraction of light through glass lenses. The refraction of light produces many effects which can be easily observed in our day-to-day life. So children, let us look into some of the effects of refraction and understand the reason behind it.
Have you observed the path of light when it enters from one medium to another in daily life? Does it move along straight line path or changes its direction? Let us observe some of our day-to-day experiences. For example, when a pencil partly immersed in water, it appears to be broken at the interface of air and water. A clear pool of water always appears to be shallower than it actually is. A coin placed at the bottom of a beaker containing water seems to be raised. When a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? Let us understand the reason with this illustration. Let us consider a water tumbler and a pencil. When the pencil is partly immersed in water in a glass tumbler, it appears bent or broken to the observer. We know for a fact that the pencil is not bent at all. It just appears to be so. In this case, the light reaching observer from the portion of the pencil inside water seems to come from a different direction compared to the part above water. This makes the pencil appear to be displaced at the interface. Does the pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene or turpentine? Will the letters appear to raise to the same height if we replace a glass slab with a transparent plastic slab? You will find that the extent of effect is different for different pair of media. These observations indicate that light does not travel in the same direction in all media. Definition: when a light ray travels from one optical medium to another, it suffers a change of direction at the surface of separation of the two media. This is known as refraction.
So children, bending of light is different in different mediums, or the light is refracted in different amounts in different liquids. So what was the reason for the apparent bending of the pencil? The apparent bending of the pencil is due to the refraction of light when light passes from water to air. So actually a virtual image of the pencil is formed nearer to the water surface, and the person can connect his eyes to the straight line path and he sees that virtual image. The actual position of the pencil is just below. Similar to the case of the fish, the virtual image of the fish appears nearer to the surface of water. Hence the person has a view of that. So all these are the effects of refraction. Besides this, there are many more examples, like stars appear to twinkle on a clear night. It's due to atmospheric refraction. A pool of water appears to be less deep than actually it is. It is due to refraction of light. The object that is placed under water appears to be raised. So all these, children, they are different effects of refraction that we see in our day-to-day life. Now let us understand the cause of refraction. Why do bending take place differently in different mediums? Children, the speed of light is different in different media. Look the figure. The speed of light in air is 3 into 10 raised to 8 meter per second, whereas that in glass is 2 into 10 raised to 8 meter per second. So it is clear from the values that the speed of light is more in air but less in glass. Or in other words, light travels faster in air but slower in glass. So what is the cause of refraction? Yeah, refraction is caused due to the change in the speed of light on going from one medium to another. So when light moves from air to glass, the speed of light is different in air and in glass. That means the speed of light is more in air and lesser in glass. So when light enters from air into glass, its speed changes or it gets reduced. And this change in speed of light in going from air to glass causes the refraction of light. So we have to note that greater the difference in speed of light in the two media, greater will be the amount of refraction of light. So we can say that glass is more optically denser than air, or we can say air is a rarer medium whereas glass is an optically denser medium. So children, let us understand what do we mean by optically rarer medium and optically denser medium. A medium in which the speed of light is more is known as an optically rarer medium. For example, air is a rarer medium as compared to glass and water. A medium in which the speed of light is less is known as optically denser medium. Example, glass is an optically denser medium than air and water. A ray of light passing from air into glass. AO is the incident ray and OB is the refracted ray. Let us draw a normal NON dash at the point of incidence O. So children, the angle between the incident ray and the normal at the point of incidence is called the angle of incidence. So here angle AON is the angle of incidence noted by the letter I. And the angle formed between the refracted ray and the normal at the point of incidence is called the angle of refraction. Here BON dash is the angle of refraction noted by R. So what happens when light ray goes from a rarer medium to a denser medium? So when a light ray goes from an optically rarer medium to a denser medium, it bends towards the normal. In this case, angle of incidence is greater than the angle of refraction. When a ray of light goes from a denser to a rarer medium, it bends away from the normal. As you can see, children, the light ray bends away from the normal. In a rarer medium, the speed of light is less. So the light ray bends away from the normal, and in this case, angle of incidence will be less than the angle of refraction. So let us clear this concept by watching the video.
In the previous video, we learned what refraction of light is. Refraction of light is a transmission of light through an object in which the light which is incident obliquely bends at the boundary of the two media. We also said that the bending of light in the medium is caused by the change in its speed. When light is traveling from an optically rarer medium to an optically denser medium, its speed decreases and it bends towards the normal. When the light is traveling from an optically denser medium to an optically rarer medium, its speed increases and it bends away from the normal. In the figure, the case above is from optically rarer to denser, and the case below is optically denser to rarer. But how does the change in speed result in the change of direction of light? I did mention in my previous video that we will understand this with the help of an analogy. For the next few minutes, just forget everything I told you about anything related to light and just concentrate on what I'm about to show you. Here's a shopping cart which has rotating wheels. Say I want to move this shopping cart from the road to the grass. Obviously, I will push it or apply a force on it. Assume that I will apply a constant force throughout its journey. Let us see what happens when I start to move from concrete road to the grass. What did you notice? As the wheels of the cart entered the grass surface, their speed reduced. The cart travelled at a much lower speed on grass than on the concrete road. And the reason for slower speed is rather obvious. The grass offers more resistance to the motion of the cart than the concrete road. Here, we can consider the concrete road and grass as two different media through which the cart is moving. Note that the direction of the cart is same in both the media. We can think about light in the same way. Something similar happens when the light is travelling perpendicular from an optically rarer to an optically denser medium. The optically denser medium offers resistance to the flow of light and hence its speed reduces. However, its direction does not change. Let's get back to our cart example. What will happen if the cart enters the grassy surface at an angle? Let us see that. This is how it would look. Now let's take the cart back to the original position on the road, and we will look at the movement very slowly. As the cart approaches the grass surface at an angle, its right wheel will enter first, and as it enters here, it will slow down. At that time, the adjacent wheel is still on the concrete road and is hence moving with the same original speed. So the wheel on the grass surface will move slower than the other wheels for some time. But let's focus on the two front wheels. Both the wheels are moving with different speeds. As the force applied is constant, what this will do is slightly turn the cart towards the right. The cart will change its direction and continue moving in that direction afterwards. So the direction changed. Now let me draw a normal to the surface now. We can see that the cart has taken a turn towards the normal. If the surface wouldn't have changed, the cart would have continued to move in this direction. But because the surface changed, the direction of movement of the cart also changed. Why am I telling you all this? It's because one can think of bending of light in the same way. When light is obliquely incident on the surface of an optically denser medium, its speed decreases and it bends towards the normal. Part of the beam that enters optical medium first slows down, making the entire beam to change the direction towards the normal. Now let me ask you a question. How will the direction of light change when it enters an optically denser medium to an optically rarer medium? Will it move towards or away from the normal? To answer this question, let's switch back to the cart example. This time, the cart is here on the grass and it's being pushed towards the concrete patch. What will happen here? This is how the direction of the movement of the cart will change. Why? Let's see the animation slowly. As the cart begins its movement, the right wheel will reach the boundary first, and after entering the concrete patch, its speed will change. Will it increase or decrease? It will increase. It's because the friction is lesser on the concrete road. So now, this wheel will move with greater speed, but its adjacent companion is still on grass moving at a slower speed. So the change in their relative speeds will turn the cart towards this direction. If I draw a normal, you can clearly see that it's moving away from the normal in this case. If the surfaces were the same, it would have moved in this direction. But as they are different, the direction as well as the speed of the cart changes. We can apply the same analogy for the light entering from an optically denser medium to an optically rarer medium. Light can propagate more easily in an optically rarer medium than in an optically denser medium. In such a case, its direction of propagation will be away from the normal in the refractive medium. One last question to which you will definitely know the answer to. What if the cart is entering the concrete like this? Perpendicular to the surface? Yes, its speed will increase, but its direction will not change. So if the light is entering an optically rarer medium in a perpendicular manner, then its speed will increase, but its direction will not change.
Let us understand the refraction of light through a rectangular glass slab. A ray of light AO is incident from air onto a rectangular glass slab PQRS at point O. So we have to do it as a lab activity. Let us just understand the theory part now. So when light passes through a rectangular glass slab, it suffers two refractions at point O and at point B on its way in and out of the glass slab. The angle of incidence is equal to the angle of emergence. The emergent ray is parallel to the incident ray as the extent of bending of the ray of light at the opposite parallel faces of the rectangular glass slab is equal and opposite. The emergent ray is parallel to the incident ray, but it gets shifted towards the side, which is known as the lateral shift or lateral displacement. The perpendicular distance between the emergent ray and the extended incident ray is known as lateral displacement D. So D depends on the angle of incidence, thickness of the glass slab, and the refractive index of the glass slab. So children, we understood that when a ray of light incidents or falls obliquely to the surface, for example of that of a glass slab, the bending of a ray of light takes place. Now what happens if a ray of light falls normally or perpendicularly to the surface of a glass slab? Yeah, there will be no bending or the ray of light will go straight. So look here, a ray of light AO is incident perpendicularly to the surface of a glass slab. And O is the point of incidence. You can see that this light ray suffers no refraction and it goes through the path AOBC. So here the light ray is entering through the normal. So the angle of incidence and the angle of refraction is 0. So children, what did we learn today? We learned what is refraction, what are the effects of refraction, optically denser medium, optically rarer medium. What happens when light moves from rarer to denser and denser to rarer. We understood the cause of refraction and also we understood the path of the light rays when it enters from air to glass and glass to air, especially the refraction through a rectangular glass slab. So hope you understood the topic. Stay safe. Thank you.